Hello everyone, myself Krishna from Sri Venkateshwara College of Engineering, studying in Systems Science. Today I am here to discuss about the phases of compiler. Coming to the introduction, a compiler is a software program that converts the high-level source code written in a programming language into a low-level machine code that can be executed via computer hardware. We basically have two phases of compiler, namely the analysis phase and the synthesis phase. The analysis phase creates an intermediate representation from the given source code. The synthesis phase creates an equivalent target program from the intermediate representation. The process of converting the source code into the machine code involves several phases or stages, which are collectively known as the phases of compiler. So there are six phases of a compiler. The first one is the lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimizer, and the code generator. This is the structure of the compiler. Phases of compiler. Lexical analysis. Lexical analysis is the starting phase of the compiler. It gathers modified source code that is written in the form of sentence from the language preprocessor. The lexical analyzer is responsible for breaking this syntax into a series of tokens by removing white space in the source code. The primary function of this phases are it identifies the lexical units that is present in the source code, then classifies the lexical units into classes like constants, reserved word, or and enter them in different tables. It will ignore comments if it is in the source program. Identifies token which is not part of the language. Example, x is equal to y plus 10, where x and y are the identifier and is equal to represent the assignment operator plus represent the additional operator and 10 is the number. Syntax analysis. A syntax analyzer receives the source code in the form of tokens from the lexical analyzer and performs syntax analysis, which creates a tree-like intermediate representation that depicts the grammatical structure of the token string. Syntax analysis is what called as parsing. Example, a plus b into c. In the tree form, where we consider the mean as star, and to the right of the star we have c, and to the left we have a plus b. So we'll take the additional operator plus as a child, and to the right side of the plus we have b, we'll take it as b, and the left we have a. Coming to the intermediate node, it's a record with the operator field and two files for a children. Leaf records with two or more fields, one for the token, another for the information about the token. Ensures that the components of the program fit together meaningfully. It gathers type information and checks for type compatibility. It checks operands and permitted by the source language. Coming to the semantic analysis. Semantic analysis is the discovery of meaning in a program. The semantic analysis phase of a compilation recognizes when multiple occurrences of the same identity are meant to refer to the same program entity and ensure that the use are consistent. Functions of semantic analysis phases are it helps you to store type information gathered and saved in symbol, table, or a syntax tree. It allows you to perform type checking. In case of type mismatch, where there are no exact type correction rules which satisfies the desired operation, a semantic error is shown. Collects type information and check for type compatibility. It checks if the source language permits the operand or not. Example, float x is equal to 20.2 and float y is equal to x into 30. So in the above code, the semantic analyzer will typecast the integer 30 to float 30.0 before the multiplication. Then coming to the intermediate code generation. Intermediate code can translate the source program into the machine program. Intermediate code is generated because the compiler cannot generate machine code directly in one pass. Therefore, first it converts the source program into the intermediate code, which performs efficient generation of the machine code for machine code. Coming to the functions, it should be generated from the semantic representation of the source program. It holds the value computed during the process of translation. It helps you to translate the intermediate code into a target language. It allows you to maintain precedency ordering of the source language. It holds the correct number of operands of the instruction. Example, taking total is equal to count plus rate into 5. We'll convert this into a simple form. Taking first T1 is equal to into float, that is 5. Then taking T2 is equal to rate into float, that is T1, rate into T1. Taking T3 is equal to count plus T2. T2 is rate into T1. So totally we get T3. Code optimization. The code of the code optimization is to discover at compile time the information about the runtime behavior of the program and use that information to improve the code that the compiler generates. Improvement can take in many forms. Example, consider the following code. A is equal to into float of 10, B is equal to C into A, and D is equal to E plus B, and F is equal to D. It can be converted in a short form that B can be represented as C into A, that is C into 10.0, and F is equal to D. So D is equal to E plus B. So F can be written as F is equal to E plus B. Code generation. A code generation is a part of the process chain of compiler which converts the intermediate representation of the source code into any form, maybe a machine code, that can be readily executed by the target system. For example, when we take A is equal to B plus 60.4, we will move, it would be possible to translate to registers. First moving R1 to A, then multiplying R2, R2 with the float value 60.0, then adding. R2 is added with R1 and stored in R1. Code linking and assembly. A compiler takes our source code and generates the corresponding assembly code. Assembler converts the assembly code to the machine code. A linker merges all the machine code modules refers in our code, whereas a loader moves the execution to the RAM and let it to be executed by the CPU. Coming to the error handling routines, in a compiler design process, error may occur in all the below given phases, whereas in the syntax lexical analyzer, there may be a wrong spelled tokens. In the syntax analyzer, we may get the missing parentheses. In the intermediate code generator, mismatch operands for the operator. In the code optimizer, when the statement is not reachable, we may get an error, whereas in the code generator, the memory is full. When the memory is full, proper registers are not allowed. In the symbol table, error of multiple declared identical. This is what is about the phases of compiling. Thank you.